Okay, so the last topic we're going to cover in this unit is percentage yield. And again, this is just kind of wrapping up chapter 9. And let's go ahead and just define this. So percentage yield is the percent of the product yielded within a reaction. And so one of the things you have to keep in mind is so far every calculation that we have done has been theoretical. We have not done any of the lab experiments or brought any of that kind of information in. All of this has just been in theory. So if we use the balanced chemical equation and we know how much reactant we start with or how much product we need to produce, we're able to figure out information from that just using the balanced chemical equation, assuming perfect ideal conditions. But what we know is that in reality, when you perform these labs or we actually carry out these chemical reactions, what we're going to find is that we're not going to produce that maximum amount. And so the theoretical yield in this equation here, it's a really simple equation. It actually looks very similar to percent error. The difference is percent error, you want to get really close to 0, where percent yield, you want to get really close to 100% yield. 100% yield means that you did a really great job and you almost achieved what the full amount or the maximum amount. The further you are from 100, kind of we would say obviously your error would be a lot bigger, but that means that you just haven't produced as much as you, the maximum amount said you could have. And so whenever we're doing any of the calculations that we've been working on, that's always going to give you the theoretical yield, where the actual yield is what we're going to obtain from actually performing that experiment. And so one of the things that you want to know is that in most lab experiments, unless there's some really big error that was made during it, you can't produce more than the maximum amount. So it's very common, and actually most often, that the actual yield is going to be less than the theoretical yield. Because remember, the theoretical is the maximum, and it would be like on a test. You can't score more than the maximum unless there's some rare situation where there's extra credit and you get everything right plus the extra credit. But typically, you're not going to get over that 100% mark or more than the maximum points. And so that would be the actual yield, would be your score. The theoretical yield would be the total or maximum. So let's look at an example of how you would use percentage yield. Now, be really careful when reading these problems, because these are the ones that just the problem itself, it might be a little difficult for you to figure out exactly what's being asked. So we give you an equation to start with. And again, we're always going to check to make sure that that equation is balanced. And so we see that there's 6 carbon, 6 carbon. We see that there's 2 chlorine on this side and there's 2 chlorine on this side. We see that there are 5 hydrogen here plus this one would be 6, and that matches the 6 hydrogen. So it is balanced already. So we don't need to add any coefficients. Everything is going to be a 1-to-1 ratio, which makes it a little bit easier calculating this problem. So this is the problem. During a lab, you react 36.8 grams of C6H6 with an excess of Cl2. So what that means is that this is, in fact, the limiting reactant, which means this is going to tell you the maximum amount of product that's going to be produced. And when you perform the lab, 38.8 grams of C6H5Cl is produced. Okay, so this right here is your actual yield. And again, notice in this problem, it doesn't say that that's the actual yield. You really have to be able to read that problem and figure out what these two numbers represent. And so from that, it wants you to calculate your percent yield. So we can first just remind ourselves that the equation we want to use is just actual yield over theoretical yield. Okay, and so this right here, we just said is our actual yield. So we have 38.8 grams, 38.8 grams of C6H5Cl is what was produced. And so what I want to do is I want to find out how many grams of C6H5 Cl should have been produced based on the amount of the reactant that we started with, and then we can multiply that by 100. But as of right now, we don't know what this value is. All we know is how much we started with, which was 36.8 grams of C6H5. Oh, excuse me, C6H6. And so what we need to do is we need to take this value and we need to convert it into grams of C6H5Cl to see how much should have been produced if everything went perfectly. So we're going to do that first by converting grams of C6H6 into moles so that we could do a mole ratio of the two substances. So we know that 1 mole of C6H6 has a mass of, I'm just going to add up, 6 carbon plus 6 hydrogen, and that gives you 78.12 grams. Okay, and now that I have the grams of C6H6 canceled out, now I can go back to my equation and figure out the ratio, and remember that everything was a 1-to-1 ratio. And so to get rid of the moles of C6H6, I'll put that on the bottom, and I know that that produced 1 mole of C6H5Cl. Now remember, the reason why I'm converting to moles of C6H5Cl is because I'm trying to find the grams of that. And in order to do that, I need to first find the moles, and then I can set up my third conversion factor, which is going to convert moles to grams. And so I'm going to need to find the molar mass of C6H5Cl by taking the 6 carbon plus the 5 hydrogen and the Cl, and that gives you 112.56 grams of C6H5Cl. And at that point, I know the grams, or I can calculate the grams of C6H5Cl that should be produced. So we're going to go ahead and plug all of that into the calculator, and you get 53.0 grams of C6H5Cl. And remember, I just rounded it to 3 significant figures since the original value had 3 significant figures. Remember, we don't take into account molar masses or mole ratios in the number of significant figures. We use the initial measurement to determine that. And so what this is our theoretical value, which we're now going to plug in here. And so we're going to just plug in that value, 53.0 grams here, and then we can calculate our percent yield. And when you calculate it, you end up with 73.2%, which, like we had talked about when we talked about percent error, is anything maybe above 90% would be a pretty good yield. But some reactions naturally just will not go to completion, and so the percent yield isn't necessarily something that's an error. It's just telling you what percent of the products you produced, and so this would be the answer for this particular problem. So here are 2 practice problems I'd like you to try. Please make sure that you use the sample problem that we just went through as a guiding example, and then you might also want to use some previous stoichiometric calculation problems to help you convert from grams to grams of another substance. And number 2 is actually, I'm going to say, is kind of an extra one. They're giving you the percent and asking you to work backwards. And so I'd like for you guys to just try that one as well, if you'd like. And then bring these into class. Remember that you have to start with a balanced chemical equation for each of these problems before you start doing any of the calculations.